In this video, we're going to be doing some soldering. We're going to turn this pile of components into this digital clock. And then we're going to put it inside this acrylic case. This is the digital clock kit by Science Hut. All right, let's get started. Here's what you get with the kit. There's a Perspex case to assemble with all the screws. A beautifully printed two-sided printed circuit board. And a tiny plastic box full of all the components needed. The only thing you need to provide is a power source. More on that later in the video. The clock kit doesn't come with any printed instructions. Instead, you can go to their website and either look at them in digital form or print them out. It includes a handy list of required and recommended tools. Then it goes into a list of every single component in the kit, showing you what it looks like and how many of each there should be. The bulk of the manual is a series of step-by-step instructions, which is basically a photograph, and it shows you where on the board to locate where to solder in that particular component. It takes you through all the resistors, the 7-segment displays, all the integrated circuits, and so on. At the end, there's a circuit diagram of the entire clock, which is handy for those of you that either understand electronics or want to learn a bit more about how this kit is actually functioning. Not surprisingly, the major tool that is an absolute necessity for this kit is a good soldering iron. It's good to get one with a proper holder so that you don't have the hot soldering iron resting on your tabletop surface, and you want one with a variable output to control different heat levels. You also, of course, need solder. Buying your solder with the flux included makes it very much easier. Also required are some wire snippers for cutting the long legs off the components. Some long flat-nosed tweezers are very handy for holding components. It's not necessary to have a multimeter, but it's very handy for troubleshooting if your clock doesn't work the first time you build it. I've got a couple here. I've got a more sophisticated one and a very cheap, simple one which will give you most of the things you need for this kit. Another tool that's not necessary but I find incredibly handy is what's known as a solder sucker. Basically, if you get too much solder on a joint, which is basically shorting to the next component, you can put a tip of this device on the solder, eject it, and it will literally suck the excess solder away. We're going to start with the 42 1 kilo ohm resistors. There's a whole bank of them on the board that sit between the integrated circuits and the 7-segment display blocks. As you can see, this is a pretty time-consuming part of the build. Sometimes I find it helpful to put a bit of tape over the components to hold them flush with the board, whilst I turn the board over, bend back the pins ready for soldering. For soldering, always put the tip of the soldering iron on the joint first, and then touch the solder to the joint to allow the heat to melt the solder and form a good bond. When every joint has been soldered, it's always a good idea to check and make sure there are no shorts, and then cut off the surplus part of the leads to keep the component flush to the board. And here I am touching the soldering iron to a couple of joints that I think have not produced a good bond. Just allows the solder to melt and reform. And here's the first group of 7 resistors. And now I've inserted the second bank of 7, and I'm going to solder them in place and trim the wires. And finally, here's all 42 resistors. There are 4 other types of resistors we're going to use, and since there's only a couple of each, we're going to use the multimeter to verify the resistance in ohms on each resistor so that we don't put the wrong one in the wrong place. Having determined which resistors are which, now we're doing the 2 470 ohm resistors. Exactly the same procedure, solder the joints and trim off the legs. And finally, we have all the resistors on the board. Now we're going to install the 4 diodes. These have to be inserted the correct way around. On one side of the diode is a black line, and on the board you can see the marking indicating where that black line side of the diode should go. Make sure you put these in the right way around. At this stage, it doesn't harm to check once again that you've got the diodes in the correct way around. Now we're going to install 4 light emitting diodes. These also have the correct polarity. The longer stem is the positive. And again, there's a marking on the board indicating where the positive leg should go. These LEDs are used for the blinking lights between the hours, the minutes and the seconds. And it's important to not mount them flush to the board, but to have them a small way raised off the board. A little tricky to get right, but bending the pins with them in the correct height above the board helps. Here's all 4 LEDs on the board. And now we're going to do the 3 tiny monolithic capacitors. Next, the 2 push buttons, which are used for setting the time on the clock. Then the crystal, which is obviously producing the timing for the clock. This has to be mounted and then bent so that the can of the component is flush with the board. Then a couple more capacitors. And a slide switch. This is used to put the clock into either the set mode or the run mode. Then the power connector. Make sure that the little screw holes point out of the board. And the single electrolytic capacitor. Like the crystal, this needs to be bent over so that the can lays flat on the board. And now it's time to put in the integrated circuit sockets. There's a couple of 14-pin sockets and 10 16-pin sockets. Each has a little semicircle indent in one end, and this corresponds with the indicated semicircle on the board. This may not seem to matter at this point, but having the socket orientated correctly is really going to help when it comes to insert the integrated circuits later. Again, tape is perfect for keeping the socket flush with the board. The best way to do sockets is to solder alternative corners first. Check that the socket is mounted correctly, and then go and solder all the rest of the pins. And here's all the sockets mounted to the board. Now we're going to work with the 6 7-segment display blocks. Each has a little dot in the bottom corner, and it's important to line this up with the dot indicated on the board. These can be a little tricky to get into the board. You have to make sure there are no bent pins. Just like the integrated circuit sockets, solder alternative corners first. Check the orientation on the board and that it's flush with the board, and then solder the rest of the joints. And here's all 6 mounted on the board. Now we're going to insert all the integrated circuits into the board. This is usually the last step once you've finished soldering everything, so that there's no heat to damage these circuits. Orient the chip using the little semicircle of the socket, if you remember that. Put the chip into the socket and then check around to make sure that when you push it in tight, it's not going to bend any pins under itself or break them off. And then you can push the chip until it clicks. Check all the pins to make sure it looks like none of them are broken or bent. And work your way carefully and slowly through all the integrated circuits. The clock needs to be powered off 3.5 to 5 volts. A battery holder with 3 AA batteries does the job perfectly. The slider switch changes the clock from set mode to run mode. And the 2 push buttons set the minutes and hours respectively. Here are the pieces for the acrylic case. Note that one of the pieces has holes that mirror up with the switches and the power block on the circuit board. And one of the side strips has 2 holes through which you can pass the 2 power leads. Pay attention because there are 2 types of bolts, a long one and a short one. First, we're going to peel off the protective coating of all the acrylic pieces. Fix the 4 spacers to the acrylic top with the holes for the components in, and use the short screws for this. Align the circuit board on top. And then position the 4 side pieces, remembering to align the one with the 2 holes with the power block. And then position the last of the acrylic piece on the top, well actually it will be the bottom under the circuit board, and screw the long screws down through the perspex, the circuit board, and into the spacers. Very nice. Finally, replace the power leads. now we have a fully functioning digital clock. So overall, this was a great project to build. It took me a few hours end to end, during which I got to solder in a whole bunch of different components. I recommend this kit to anyone interested in electronics, and if you're totally new to the hobby, take your time on this one and make sure you double check every component is going in the right place, and in many cases the right way round. So good luck and happy building! Thanks for watching the video. If you like this content, please subscribe, please give it a like, and I'll see you in the next video.